So the last lesson in this notebook is, or excuse me, the last problem in this lesson is 5 or good gravy. I feel like I should start it all over again, but it's getting late and I want to go home. So we're not going to do that. 5-25. Rob decided to play a card game with his friend Travis. He told Travis that if he picked a black card with a value of 9 or greater, Travis would win. Jacks, queens, and kings are considered to be greater than 9. If Rob picked a red card with a value of less than 9, Rob would win. Aces are considered to have a value of 1 in this case. Aces are kind of weird cards that sometimes they can be larger than a king or less than 2, depending upon what game you're playing. So Alpha says, what's the probability that Travis will win? But I think we need to write down which cards will make Travis win. So again, Travis picks, he's going to win if he picks a black card with a value of 9 or greater. So we need to list out those right here. Let me move my keyboard out of the way. So Travis wins if it's 9 or greater. So I have a 9, and we have 10. There's no 11. We have jacks. We have queens. And we have kings. But it's not all of them or just one of them. It's the black ones. And so of a king like this, how many of those are going to be black cards? So there should be 2 because it's going to be the spades and the clubs. And that's going to be true for all of these. There's 2 queens, 2 jacks, 2 tens, and 2 nines that are black. So how many cards out of the deck is it going to be that Travis wins? How many cards will make him a winner? So I see 10 cards will make him a winner. So we're going to do the same thing with Rob, for Rob being a winner. So Rob is a winner if he picks a red card, so different color, with a value less than 9. Okay, so less than 9. So not 9, but we have 8 and 7, 6 and 5, 4, 3, 2, and of course our ace. How many of these are going to be red in the deck? Of the 8s, only 2 of them. 2 7s, 2 6s, 2 5s, 2 4s, 2 3s, 2 2s, 2 aces. So how many cards is it that's going to make Rob a winner? I see 16 cards. This is usually the spot that I ask whether or not this game is fair, because kids can already know whether or not it's going to be a fair game. Does Travis and Rob each have an equal chance to be a winner? They both have an opportunity to be a winner, but are they equal? No. So this game is not fair because Rob is more likely to win. They don't have an equal chance. So probability for Travis to win. Remember, probability is what you want over the total. What I want is his winning cards, which is 10 cards out of the 52. Rob, on the other hand, what I want over the total, probability for Rob to win is going to be 16 over 52. And again, this is larger than that one. I want to keep those denominators the same so I can compare them, right? But we already knew from up here who was going to be the winner, chicken dinner most likely. Can Travis still win? Sure. Is it fair though? No way.